Hello everyone, and thank you for joining me today to learn more about SOLIDWORKS API. Today we're going to be building some basic macros and getting familiar with the tools that we can use to help us develop our own custom macros. Starting off with the macro recorder. The macro recorder will allow us to record specific commands within SOLIDWORKS and produce the code to automate those commands. From there, we'll take a look at the VBA Editor, get familiar with the interface, and do some light debugging of the macro we recorded. From there, we'll investigate the object model, which really gives SOLIDWORKS API some hierarchy, and understanding that hierarchy can help you be more efficient when we're navigating the available interfaces and methods. Speaking of the interfaces and methods, the documentation is going to include all that information along with some great example code that we can utilize to start our own macros. We'll take our recorded macro and add a user form to it as well to extend the functionality and allow some user input. And finally, we'll wrap it up with a macro that will replace the sheet format in a variety of drawings within a user-supplied directory path. To get started with the macro recorder, the first thing we want to do is enable the macro toolbar. To enable the macro toolbar, we just need to right-click anywhere on the command manager, hover over the toolbar submenu, and click on the macro option. You should see a similar toolbar like this shown where we have 5 different commands, the primary one here being the record button. Once we click on record, it's going to start capturing every command that we are manually performing. We can also pause the recording to prevent it from capturing, zooming or rotating commands that we typically don't need when we're looking to automate a given task. And once we're done, we'll use the stop recording to end the capture and ultimately save out the macro that we have recorded. We do also have a run, new, and edit. So run and edit will allow us to interact with existing macros. And if we want to create a macro from scratch, we can use the new macro option. We're going to make a very basic recording here. We're going to sketch a circle and then apply an extrude to our sketch to create a cylinder. In my part in SOLIDWORKS, the first thing I want to do is enable that toolbar. So again, I'm just going to right-click anywhere in this command ribbon, hover over our toolbars, and enable the macro toolbar option. It's going to put it up here. We can drag it out if we'd like. And we're going to use the record button to begin the recording. So I'm going to go ahead and sketch on the front plane, just like I would normally do to draw a circle. We'll apply a dimension to fully define our sketch. Just make that 5. And then we'll apply our extrude. Again, I'll go with 5 here just to keep things consistent. And now we have our cylindrical extrusion. So I'll go ahead and stop the recording, which is going to prompt me to save my macro. Now, I would always recommend, once you've recorded a macro, to go ahead and test it on a new part. So since I already have this extrusion in here, I'm going to go ahead and generate a new part file. And I'll click the run option, which should bring me back to the directory I just saved in. And we'll run the macro. Now we can see here that once the dimension is applied, it's actually prompting me to accept. So that might be something that we want to ultimately change the behavior for our macro. Now I'm going to go ahead and click the green check, and you'll see that it does update that value to 5. So it is still setting the value to what I actually recorded. But we can see our ultimate output is a cylinder. The macro did perform without any error, so that's a good start. We'll see in the next section how we'll do some debugging with this macro and see what code was actually generated. So with the macro recorder, it's really how I start most of my development. It provides a really quick and easy way to capture a given workflow. And it may just be a small subset of your overall functionality that you're trying to achieve, but it's a great way to get started. So now we're going to take a look at the VBA Editor and get familiar with the interface and do some light debugging on the macro we just recorded. If you're familiar with the VBA Editor in any of the Microsoft Office applications, you're in a good place because it's going to be the same interface. If you're not, there are a couple panes that you should be familiar with, starting with the Project Explorer. This is where our default module is going to be created and any other user form or classes that we might manually add to our macro. There's also a properties window, which is really going to be important when we get into user forms. If we want to control the font of a given label, for instance, we'll have to modify those properties. We also have a locals window, which is going to show us any variable within a given subroutine. During the debug, it's going to give us the values of those variables. Now, if you have a lot of variables in a given subroutine, we can set a watch, which will limit the scope of what variable values we're seeing. In the VBA Editor, if we want to do any debugging, we need to set these breakpoints. And so we can select in the left column, if we click in there, it'll set a breakpoint. Or if we select anywhere in the row and press F9, it'll set that red breakpoint. When we set the breakpoint, then we can initiate the debug process using F5 or that play button. And then we use F8 to step to the next lines. As we step through, we'll see in the locals window the variable values that are within the scope of the current subroutine. Or if we're using a watch, we use the watch window to see what those values are. Okay, so return to SOLIDWORKS. We use the edit macro option here, and let's edit our macro we just recorded. So the first thing I would do if I just wanted to kind of step through the code, get familiar with what the macro recorder output is, I'll go and set a breakpoint, one of the first methods here. So we have a select by ID 2. Click in this left column to set that breakpoint, and then I'll use the run or F5 button to begin debugging. I also might want to go ahead and start a new part document again because I already have an extrusion here. I'll go ahead and snap this to the left side here so we can actually see SOLIDWORKS as we're going through. So once I click play, we'll see the line highlights yellow, and that's the active line, and it stops on our breakpoint. We can use the step into or the F8 key to progress to the next line, and we'll see that highlight color moves. And we can also see in the viewport that the front plane is now selected. So that is what we're getting with the select by ID 2. Then we enter a sketch, clear the selection, and we sketch our circle. From here, we're selecting the circle back, adding a dimension, and we can see here that add dimension to is when we are prompted for the dimension. There might be something that we need to look into here to prevent that user interaction. And then finally we have the extrusion added, and that is the end of our macro. So we can see how we can step through each of those values. As we're stepping through, the locals will be updating. So if we need to check, for instance, this bool status, which really lets us know whether or not the selection was successful or not. So if we're having an issue with a selection, we might use the locals window to watch for that value, whether it's true or false. Now, when we use a macro recorder, there's some things that are important to know. One is early binding versus late binding. When we use the macro recorder, it will always use the late binding. In other words, it'll show dim SWApp as object, dim part as object, rather than early binding, which calls out or specifies the type of those variables. So here we see in the early binding, we're using SLDworks.SLDworks for the SWApp variable. And the benefit of that is that you're going to have the IntelliSense give you the appropriate methods and properties of that particular interface. The macro recorder is also going to have some extra stuff in there that we don't really need. One thing to know when we're working within the API, when we programmatically create an entity, for instance, when we create the circle within our sketch, it will always stay selected after creation. With that being said, we really don't need any select by after the creation of the circle, which they're doing so to make sure that the dimension is applied to the arc. So since it stays selected, we really don't need that line. We'll be safe to remove that from our code. We also don't need to clear our selection for the most part, right? A lot of times you'll see in the recording that it will clear the selection and then select it right back. So we don't really need those clear selection twos. We also don't need view changes. So when we, for instance, went to do the extrusion, it changes to a trimetric view. When we're trying to automate the task, we just don't need that extra action. It should be all automated, so we can safely remove those. Now, if you're ever not sure if it's safe to remove, we can always comment the lines out with an apostrophe and run through the debugger. That way, if things go sideways, we can always uncomment it and bring that line of code back. So we saw when we debugged it, some updates we might want to make is prevent that modify dimension dialog so that it's fully automated. And we'll also want a user form so that we can input the depth and or diameter for our cylinder. If we want to test out commenting those lines out, we can go back into our editor here and do another test without the unnecessary lines. So we have a clear selection 2. We really don't need that. We don't need to clear the selection after creating the circle. And we don't need to reselect the circle after creating it because it will stay selected. So we can comment or delete all these out. And like I said, we can also comment the lines if we're not sure. For instance, like the zoom to fit. If I put an apostrophe there, you should see that line turn green. So we can also take out the trimetric view manipulation. So if we test this out again on another new part, I'll go ahead and just remove my breakpoint and press F5 to let it run. Still have that modify dimension dialog, but we can see that the cylinder is still created without any errors, without those lines of code. So we use that editor to modify our recordings, or really any development of a macro, you're going to use the VBA Editor if you're programming with Visual Basic. We can also use the debug to find any errors, watch the locals or watch windows to check for the values of our variables as we progress through the code. Next, we'll discuss the object model. When we refer to the object model, we're really referring to the hierarchy that makes up SOLIDWORKS API. As you can see in the diagram to the right here, the SOLIDWORKS interface is the top level. We'll always have some pointer to that interface in order to interact with the SOLIDWORKS application. Second behind that is the model.to interface, which really represents any type of document we might have open in SOLIDWORKS. Now, if we need access to specific functionality, say in a drawing that manipulates a view or an assembly that manipulates a mate, we may need to get a pointer to some lower level interfaces like part, assembly, or drawing doc, which implement model.to, which is to say a part doc is a model doc. So we always need some higher level object to access, a view. For instance, we need a drawing doc. Understanding this hierarchy will help us navigate the API. Most common ones, like I said, we always need an SOLIDWORKS. We always need a model.to if we want to interact with any document within the application. But we may need, from there, a part or assembly document, depending on what task we're trying to automate with the API. So the object model just provides that hierarchy. It's something to keep in mind as you're going through the documentation, which we'll look at here next. The documentation is going to include all the information we need in order to develop our own macros. The help is your friend. Make sure you're using it because it has every interface, every method that we would need to interact with. It also includes some great examples. This help file is located either online or locally within your own SOLIDWORKS installation directory. So by default, that's in your C program files folder. I prefer the offline or the local version because I don't need an internet connection to get to it. It's also very fast. As I mentioned, there are numerous code examples. So it's a great way to, if a lot of times there's a similar example code within the help that you can copy and maybe modify or manipulate as needed for your own project. When you're using the help file, you're going to see most of the items in the help start with the letter I for interface. So if you're using the local help file, there's an index and a search tab. We'll always want to use I and then the interface name. So I model doc 2 will return results better. Speaking of items that start with the letter I, you might see some methods that start with an I as well. Methods that start with I are for in-process only applications. So this includes add-ins and macros. An in-process method is going to return type-safe objects. When we're talking about VBA, it really doesn't mean a whole lot because VBA does automatic typecasting. But if you're using a language like C#, it is helpful to understand what those in-process methods return. So we can see with an SW model or an I model doc 2 interface, if we use the I active doc method, it's going to return a model doc 2 type object. Whereas if we use the non-in-process method without the active doc without the I, what that returns is just a generic object which we would then have to cast manually to a model doc 2. Also within the help file, we can get a list of accessors for a given interface. So for instance, if we need to access a view, we might see what the accessors for an iView object type are so that we know how to navigate that hierarchy to get to that, to get a pointer to the view. You can also use the access diagram, which is more of a visual roadmap of these relationships. So here we can see the part doc to the left, model doc 2, and belt chain feature data. Typically what that means is we can access a part doc type object from those two interfaces, right? We know model doc 2 and part doc are, or part doc implements model doc 2, so they are almost equivalents in that nature. And we can see that on the right where model doc shows up on both sides, which allows us to do something like SW model equals SW part, especially with VBA with the automatic typecasting. So if you're using local help, it'll look something like this. Up here at the top, we have the index and search. I primarily use the index. So if I wanted, for instance, the model doc 2, this is where you want to type in I model doc. And you can just double click on those items to show the information. So we get some general syntax information, which if we're looking at a method, it'll show us the parameters or the inputs we need. You also see that there's a section for examples. So depending on what language you're using, there's oftentimes an example for each language type. Some general remarks that might be helpful, and the accessor list. So to get the model doc 2, for instance, we can see that from SOLIDWORKS we have this I active doc property. So those are all ways that we can obtain a pointer to an I model doc 2 interface. Now we know when we went through the debugging that there's some modification we want. For instance, we want to prevent the modify dimension dialog. We also know as we step through and debugged our code that the add dimension to method is when we saw that prompt for the modify dimension dialog. So we'll take a look at that line of code to prevent that dimension dialog from showing. And if we actually looked up the add dimension to method, we would find in the remarks that it directly references the fact that we have to manually click on the check. And to prevent this, we can toggle the user preferences. So in the code, if I look at this add dimension to, copy that out and bring it into our help file, you can see here that there's an add dimension to for model doc and model doc 2. Typically, you always want to use this latest version, and if we look at the iModel doc, it shows obsolete or superseded. So we can click on those links to navigate. And if we look down in the remarks here, we see that line where it talks about setting this preference so that we don't have to, or that we can suppress that dialog box. And so if we click on this, it'll take us to this property or this method for the iSolidWorks interface, where we have to provide it with an integer value. In this case, it'll be an enumeration for that integer value, and whether or not the checkbox is on or off. So here's an example of how it's used, and really this is just toggling any of the system options that we have available. And so if we want a more of a interface type, we can actually navigate through here, and it'll show us the pages and show us the potential toggles that we can change. Now in this case, they do provide those values. So I'm just going to copy this line out and put this towards the beginning. I'll just do it after we set our SOLIDWORKS app pointer. Now, the integer value we want to use, instead of folder rules, we want to control the dimension input. The remarks on the add dimension to show us what this enumeration value is, or member. So I'm going to copy that out, and I'll go ahead and replace the existing value with this input dim value on create. Now, we don't want to input the dimension value when a dimension is created, so we'll set this to false. Now, if we're changing user preferences within our macros, I strongly recommend setting them back to the way they were. So I'm going to go ahead and copy this line, and at the end of my code, we'll set this back to true. That way, if someone runs their macro there and they use smart dimension later on, they'll actually be able to put those dimensions in. So let's give this another quick test. Go into SOLIDWORks here. I'll just pick up another new part. Go and run our macro. And now we can see that it's not asking us to input a dimension. And we did set it back on, so if I were to come in and do a new sketch and apply a dimension here, it is going to prompt me to enter that value. That's how we can use the documentation to improve or expand upon our code. The documentation is a great resource to have handy. Create a bookmark or create a shortcut to the local file. It's going to contain all the information you should really need, along with those example code snippets to really give you a great jump start. Or there may be even an example that does exactly what you need in there already. Okay, now we're going to add a user form to the macro we recorded. We'd like to get some input from the user, maybe to specify the diameter. To add a user form to our macro, we just right-click within the Project Explorer, go to Insert, and User Form. Once the user form is added to the project, we'll be given the option to add controls to our form with the toolbox. So we'll add some label, text box, and a button to initiate the creation of our cylinder. Now the button's going to be the start to run the macro, and so we need to tie an event to that button. What happens when it is clicked? And to do that within the VBA Editor, we just double click on the control to access or create a subroutine for that click event. Also want to note, since we are putting in dimensional values here, that all dimensions within the API use meters, radians, kilograms, or square and cubic meters. And so if we're working within inches or millimeters, we do need to convert those inputs to the system units. The user unit interface can do those conversions for us, both from or to the user unit or the system unit. And we can also convert string data that include equations or units within them into actual dimensional values. So if we take a look back at our code here, what we're going to do is add in a user form to alter our diameter. So the first thing I'm going to do is go ahead and add in my user form. I'm going to right click in this Project Explorer, go to Insert, User Form. So here's our form. Here are the toolbox of controls we can add. So the first one I'm going to add is just a general label to let the user know what value we're inputting here. So this is going to be our diameter. And then we need a place to input the value, so we'll use the text box control. I'm going to go ahead and name this one my diameter text box, so that when I call on it in the code, I can use an easily recognizable name. Now, after we're done inputting the diameter, we need a way to kick off the creation of the cylinder, and so we're going to use a button for this. And if we just click in here, just like the label, we can update that value. We'll call this build. And so to assign an event to this button, we're just going to double click on it. And what this does is it switches the active window to the code behind the form. And we can see in this drop down here the various controls on our form. Here we have our command button. And whatever's selected here, we have the events for that control on the right. So what happens, for instance, when we click on the button? So when we click on the button, what we want is we want to run the code within our macro 21 module here. If I double click on this, it'll take me back to this window. Now, I like to use the main subroutine as my entry point. So this is actually where I'm going to show the form. And I'm going to take all the code within the subroutine and cut it into its own sub. So we'll call this create cylinder and paste that code in there. So now I need a way for when the macros run to actually present the user form. To do this, we'll just call on the name of our form, so user form 1. And one of the methods for a user form is to show that form. So this will now present the user with this dialog. Now when we click on this button, we need to actually call that new create cylinder subroutine. So if you press Control J, it'll give you this IntelliSense. Here we see that control create cylinder. Now, if we were to leave it as is, when we click the button, it's just going to create that 5-inch diameter circle, and it's going to extrude it 5 inches. In order to take the user input, we need to create an argument for this method. So once again, I'm going to go back to my macro 21 here, and we're going to modify the signature of the subroutine to include an argument for the diameter. So in order to allow the user to input decimal points, we'll accept a double value, and we'll pass it as a bival reference. Now this diameter is going to be used for the dimension, so instead of having this hard-coded value in here, we're going to reference this diameter argument. So our subroutine's all ready to go. We have our user form showing. Now we just need to make sure that the user form, when it's calling this create cylinder, is passing the text value that the user is supplying in the text box. And so this is where we have the diameter text box control, and the property of that text box of text would be the value that the user enters. All right, so I'm going to go ahead and clean up what I got open. I'll just close all these open documents. We'll start another new one here. And we'll go ahead and run from our main subroutine. See, it presents the user form. Go with a diameter of 5 and build our cylinder. Now, it is very flat, very large diameter, and the reason is when I set this to diameter, remember this is using the default system units of meters. So we're actually creating a 5-meter diameter circle rather than 5 inches. This is where we would use user unit interface to convert this, or you can even hard code this in if you'd like. So if we divide by 39.37, that's meters to inches. And if we run this again, we should see an appropriate sized cylinder. So with our user forms, we can extend the functionality of our macro to accept user input. Maybe it's varying in size, or we might be prompting the user to select a face on the model, for instance, before it moves forward in the macro. So we're going to take everything that we've covered and generate a process to update drawing sheet formats in bulk. So this is going to take a combination of our macro recorder, some debugging. We're going to have a user form for user input so that we can specify, what folder needs to update. So we're going to use the macro recorder to swap out the sheet format. We'll go and test and debug our code in another drawing to make sure it's working appropriately. Create a user form to prompt the user for a directory path and a path to the template they wish to update to. And we'll go ahead and run it on a given directory to make sure it works. So we'll have to modify the code in order to loop through a directory. Again, I'm going to go ahead and close out all my windows here. And I got a sample drawing. I'm going to go ahead and open this dial. Okay, so this dial right now is using an A size sheet. We might want to swap this out with a new format of A, or maybe even swap out the A size with a B size. To swap out the sheet, what I'm actually going to do is just do the recording to see where it starts me off. So I'll go and record, swap out the sheet format from my properties here. We'll go with the B size, and while I'm here, I'll copy that path. So we have the larger sheet now. We'll go ahead and stop that macro from recording. And let's go and edit that in our editor. Let's see here, this one's pretty short, but this line is the line that we're really interested in to swap out the format with a new path. So what I would recommend when we do this on one file, let's go and test it out with another drawing. Try out this latch. So we'll go ahead and run the debug, and everything works as expected. So that looks good. I think we're ready to expand the macro to include some user input, and then also expand the macro to iterate through a directory for drawing files. So again, I'm going to go ahead and close all these out. The other thing that the macro recorder didn't get is the actual open process, because we already had the drawing open. So we could record that. I'm actually just going to go and add this to the code from here. So first thing I'm going to do is add a user form. And for this user form, we'll go ahead and have two labels. We'll have the directory path and the template path, or the sheet format path. We'll have two inputs for user to enter the directory information. And we'll go and name this. We'll call this directory path, and I'll copy that for the sheet format. We'll call that the sheet format path. Again, we'll include a button so that we can use that to start the process. Okay, so our user form's looking good. Go ahead and double click on our button to create the event. Again, everything that we've recorded is going to be in the main subroutine. So I'm going to jump back here and just copy this data out. No, do it from here. Copy this into its own subroutine. Okay, so now we'll make our button call the update. Again, we're going to want those inputs from the user, so we'll create the arguments for our update subroutine here. We're going to have two inputs. We'll have the directory path as a string, and we'll have the sheet format path as a string as well. So the sheet format path, we can actually go ahead and replace what's in this callout, that path that we had manually replaced it with the variable. So now whatever the user enters, this is the format that will be used. We will use the directory path as a way to open all of the drawings in a given directory. Now this one's going to take a little bit of manual updating. The first thing we need is the file path is a way to get the file path from our directory. And to do that, we'll go and declare a file path variable. And we'll set this file path equal to dir directory path. And we can include a wildcard here of ***SLD_DRW. And what that'll do is limit what files are seen by this dir command to only our drawing files. So dir is a special VBA command to help loop through file directories. Now we want this to run for every file, so what I'm going to do is use a while loop while file path is not equal to blank. So what happens with the dir command is when we reach the end of all the files in a given directory, it'll return a blank file path, which will take us out of this while loop. So once we have the file path, now we actually need to open those drawings. And so we can see here part is set to active doc, but in order to have an active document, we actually have to open it first. Instead of using active doc, we can actually use open doc. So OpenDoc 6 and 7 are the latest version or methods for opening files within SOLIDWORKS. Let's go ahead and check out the help file for our OpenDoc method. And so here we can see that we need the file name, the type, options, configurations, errors, and warnings. So the file name in this case is going to be our directory path plus our file path. And really, this should be this isn't the full path, it's more so the file name. So that's why I'm concatenating those two here. Now we're only interested in drawings, so the type here is also an enumeration of different types of documents. We can click on these hyperlinks in the help to see what those enumeration members are, and you see here this SW_doc drawing corresponds to a value of 3. Now I would recommend to use the member name because it's more readable, and so we'll paste that into our OpenDoc 6 parameters. See the options. The options here for opening our documents are going to be related to, are we in lightweight mode, or how do we want to handle the references opening? For this, to keep it quick, I'm just going to go with the silent option. So configurations, if we select this, it does mention how this only applies to parts and assemblies and not drawings. And if the argument is empty, or the configuration is not specified, it'll just use the latest version. And so for drawings, what we do is just pass an empty string here. Now these last two by ref, what that means is that this is going to return a value to an errors integer and a warnings integer. So I'm going to go ahead and declare some new variables for those errors and warnings. I actually have a long warning up here. I can use this. And we'll dim long errors. Using that Control J for the IntelliSense set. So I don't have to type it all out. And there should be the completed OpenDoc. And we can see also OpenDoc returns the model.2, which I'm using for my part. So you can see here that we have some selections and clear selections. As we talked about, these aren't really necessary from the recording, so we can safely remove those. We also see that this is only swapping out sheet 1 we might want to have some sort of loop inside the while loop that loops or iterates through all the available sheets in a drawing if we want to make sure we're replacing every sheet. If all your drawings only have one sheet, then you probably don't have to worry about that. But you might want to, instead of hard coding sheet 1, we might want to get that sheet name from our part doc here. But as it stands, we have our loop, we have the file opening, we have the sheet format being swapped out. Really the only thing we need next is to get the next file path and close out our while loop. So to get the next file path, what we do is just call dir with no arguments, and it'll find the next drawing within our given directory. And then we need to end our while loop. So we'll go ahead and give this a test now. Press F5, it's going to ask for our directory path. Let me go ahead and grab that from my sample files here. Use my clipboard history and pull that sheet format path as well. I forgot my argument. So when we have an error in our code when we're running, it will stop before it errors out. And so here, this is where we actually need to pass along the directory and sheet format path. So I got my directory, again, Control-J will give me the IntelliSense, and we're using the text property of the text box. Same with the sheet format, we'll use the text. So you can update that and then just hit the continue button, and it will start processing the rest of our files. And so we can see now that it's opened all 4 drawings. And if we look at the size of the sheet, it is a B size in every single drawing it's opened. So a very common request is bulk processing your models to make changes or apply changes to a large subset of your data. So using that dir command, that's a quick and easy way that we can cycle through all the files in a given folder and have your macro execute on every single file. Just a quick recap of what we covered today. The first thing we saw was a macro recorder where we were able to capture a workflow that we perform manually and output the VBA code to jumpstart our macro creation. And then with the VBA Editor, we were able to step through the code and do a bit of debugging to see what all that was captured with the macro recorder is necessary, if we could clean it up and make it a little bit more readable. And we looked at the object model, showed how we have a hierarchy associated with the SOLIDWORKS API to really help us traverse this pretty vast library that we'll interact with to create our macros. Of course, the documentation is going to be there to help with the parameters of given methods or find the accessors for a given interface if you're needing to do any manual programming that maybe the macro recorder doesn't capture. Again, there's a plethora of example in the documentation as well that you can use to as a starting point for your own projects. Introducing UserForms in your macros is also a great way to extend the functionality and get that user input. Sometimes maybe it's not possible to programmatically select a face and you need that input from the user. And finally, we saw with the bulk process, the real key there is having using the dir command to cycle through and iterate through the files within a given folder. Again, I want to thank you guys for joining us today. It's been a pleasure having you. If you have any questions, make sure you're posting those in the questions in the webinar. And if you have any questions after the webinar, be sure to reach out and let us know. We're happy to help.